All right, in this video, we're going to do our last density problem using the ideal gas law. And afterwards, you should be able to go to the learning goals to practice all types of problems with density, molar mass, and ideal gas laws together. So what we're going to do is we're going to try this problem out. When you're done that problem as well, I do recommend you try the pause, try, play videos. There's extra practice problems with density there. So you can try the problems, play the video, and see if you're on the right track with them as well. Just extra practice. So let's go over here to our last problem in our handout. We have a gas with a density of 3.01 grams per liter at STP. What is its molar mass? So you could go ahead and do all of this, these long steps, just slightly different in different ways. Because you're given a density this time and you want to find the molar mass. So you might have to make different assumptions, but you could probably still figure it out with assumptions. I do recommend you try to solve this in a different way than just using the formula. I'm going to show you how to do this using the formula. And then you can try to solve it using a longer method, but a logical method. Try to experiment and see what assumptions you can make to try that out. It is a skill. It does take some time to make those assumptions, but it is great practice if you try it out to see if you can get to the same answer. And even if a bit of it is trial and error at first, that's okay, because eventually that trial and error can turn into some kind of understanding afterwards. So guess and check is okay at the beginning of your learning. So remember, we have our formula. Density is equal to, we derived it earlier, pressure times molar mass over, that's a P, by the way, pressure times molar mass over RT. Now, we have density given to us, 3.01 grams per liter. We have pressure as well at STP, right? So pressure at STP, as we used earlier, is 101.325 kPa. So 101.325 kPa. We have temperature given to us as well at STP. At STP, it's 273.15 Kelvin. So 273.15 Kelvin. And we have our R value. If we have, as long as we have our liters there for volume, our pressures kPa, and our temperature is 273.15, we can use the 8.314 kPa liters per mole Kelvin. So that's our R value there. And we want to find we have our density as well. Sorry, it's given to us. We don't want to find our density anymore. We have that provided. Instead, what we want to do is we want to find our molar mass. That's what we're looking for in this case. Why don't we just use our periodic table? Well, we don't know what that gas is. We don't know what it is right now. So we can rearrange to find molar mass. We know that molar mass is equal to the density times RT, because we send this to that side, all this here, and then this to the bottom here, so over pressure. And we're going to get 3.01 grams per liter multiplied by 8.314 kPa liters mole Kelvin multiplied by temperature, which is 273.15 Kelvin, over, I start crossing out prematurely, but that's okay, over our pressure, which is 101.325 kPa. We'll cancel out our kPa's just like we did our Kelvin there. We'll cancel out our liters over here, and we're left with grams and moles in the end, grams per mole, which is what we want for a molar mass. So we'll go ahead and do that. We'll do 3.01 times 8.314 times 273.15 divided by 101.325, and we'll get about 67.4622941 grams per mole. And then we can round that to 3 sig figs, so approximately 67 point, so this would go up to 5 grams per mole as our molar mass. So therefore, the molar mass of the gas that we don't know is 67.5 grams per mole. And so this was again using the density formula, except we had to find the molar mass rather than the density this time. And I do encourage you to try to solve the problem using some assumption methods, see what you could assume and see how you can use those assumptions to solve the problem in a different way and see if you can get to the same to the same answer. If you go to your unit calendar over here, you can take a look at the filled in versions. And the filled in versions have essentially the steps that you saw in the video, but just to show you over here, you can take a look at an alternate method that was used to solve the problem. And so I do recommend you try to come up with an alternate method and see if you can get that alternate method. If you can't, you can come and take a look at what alternate method was used there. So in this filled in version, you can see that the longer methods are used rather than the formulas. So I'd recommend that you try to use the long methods and then use the formulas, to save some time, but I want you to understand those longer methods as well. And so that brings us to the end of our video lessons for the ideal gas law formula. Do make sure you practice them very well, because we will be using the ideal gas law in a stoichiometry context in our next lesson.